Hello everybody, my name is Colin Frisky. I'm back at it again with another tutorial. This one we are continuing our Match-3 tutorial, so this would be part 2. Where we left off is we basically generated a random 2D array of pieces from our node class, and then we just we checked if there's any connections and we got rid of them if there was. So when you start the game, or when it loads up, there will be no matches currently. That way you have to move a piece to kind of get it started. We also got our board layout working, where we can kind of change the board layout by checking in some holes here. So a check mark means it's a hole, and you can see now, once I unscale it, you can see there's a hole now in there. So today what we'll do is we'll be getting the movement done and kind of getting the pieces to fall off. So we'll start by going back into Match-3. Just if you guys did miss this part in the last one, make sure in your isConnected function, I kind of messed up. Make sure that in these in the loops, in the checks, you want to be adding the point that you get the value of. So you see we're getting the value of check. Make sure that then you add check. Same down here, we're getting the value of next. We're going to add next. I messed up and I put P in a lot of these, and so just to getting value of point, we're going to be adding the point. So today what we're going to be doing is, now that we have them connecting, we need to basically interact with the pieces. And so we want an interaction system that works both with PC and Android, just out of the blue, or out of the box. So Unity actually has a good built-in one of that. So what we're going to be doing is we're basically going to be going into our node piece. So this is our piece. This is on each of these images, and what we're going to be doing is we're going to be inheriting some parent classes. So what we need to do is, first we need to add using the Unity Engine event systems. So this is Unity's built-in event systems. Basically, it kind of holds some classes to use the event system that you can see here right here. So we have an event system for each canvas. Make sure you have that event system, but it's normally created when you create a canvas, so you shouldn't really have to worry about it. So we're going to be doing a down handler and an up handler. So what this is going to do is it's going to make us be able to see when we grab it and when we let go, basically. So I think I can just, yes, so yeah, can I document, I'll enter and document apply. Okay, so you can see now, once we do that, once we go up there, and you can just create these, the public void on pointer down and a public void on pointer up. I just figured that would be easier. I didn't know I had to click so much, but oh well. So what this is going to do is, now we can see if I debug log grab plus transform name. So I'm going to tell that I'm grabbing the transform, and then I'm going to let go of. So once we go in here, now that we just added those, you can see it automatically kind of like throws it into our node pieces, because that code's already on each one. So when I click, ooh, let's see here, method, well, why would I do that? Get out of here. I don't want you. Stop throwing that, making me think I have an error. So let's try that again. So we grab here, we're grabbing node 6, we let go of node 6. So let's grab this one, grab, let go. So this is basically lets us kind of figure out which piece we're grabbing easily and just going from there. So what we're going to be doing is we're going to basically be kind of updating these node pieces. So I'm just going to create a bool so I don't have to basically, if I'm already moving the piece, I don't want to grab it again. So if updating is true, then we're just going to return. And then we're going to want a public void update node or update piece. That way I can just kind of figure out, or yeah, basically figure out if we're updating or not. So what we're gonna do is I'm actually gonna return a bool, and so what I'll do is I'll return true if we're still updating a piece, like it still needs to move, or we'll return false if it is not moving, basically. Alright, so now what we have to do is kind of handle the movements. So it's actually going to be easier just to create a new script for that. So I'm just going to call it the move pieces. And on Match-3, I'll just drag this into here. So what this will do is it'll basically kind of keep track of the movements. Can I open you? There you are. So I'm going to need to be able to call this from anywhere. So I'm just going to create a static move pieces instance. And then create the void awake instance equals this. On start, I guess I should Match-3. I need the game just to kind of, I'm gonna have to do some stuff with the grid, the 2D array that's in there. I'm gonna need a piece that I'm moving, so we'll do that. I'm gonna need a point to the new index for that piece. And I'm going to need the mouse start, basically where our mouse is or where the touch is when we click on it the first time. So on start, let's get the game since we have it in the same transform. Let's do that. And then in the update, so if we have a moving piece, or if we don't have a moving piece. If we do have a moving piece, I just wrote it out fully. So if moving is not equal to null, so if we have a piece that we are currently moving, let's get the direction from our vector2 of our mouse position. So mouse position. And we are going to get mouse start. So we're basically getting the direction from the start to where we currently are. I'm just gonna get a normalized version of that. And then I'm gonna get an absolute version of this. So new vector2 math absolute mouse Sorry. What did they name it? Oh, that's right there. Dir. I know what it is. Alright, and then math up absolute dir.y. So this gets our current position from where we started. And so let's set a new index, or our new index to point. We're gonna clone it this time, so this is why we kept the clone function, because if we would just set it equal to what the moving index, if we would just set new index to moving index, when we change new index, so would the index of moving would change. So we just want to clone that value at this time instead of fully doing it. And we're gonna make a new point that we're gonna call add. That's what we're going to be adding to the new index after all this. So if dir.magnitude is greater than 32. So if our mouse is 32 pixels away from the starting point, basically, of the mouse, So basically, we just kind of give it a leeway of 32 by 32. Basically, if your mouse is still within the 32 by 32, we're not going to move you. But if it is greater than, then we need the absolute direction of x. Is it greater than the absolute direction of y? So if our x is basically a bigger value than y, either negative or positive, it doesn't matter because it's absolute. Then we're going to make a new point using whether or not the direction or the normalized direction is greater than 0. So if our normalized direction is positive, then we want the positive. If it's negative, we want the negative, kind of thing. Else, if a dir y is greater than a dir x, then we want basically the opposite. And dir x, sorry. We want the opposite. Instead of getting the x, we want to get the y. So this will make add either 1, 0, or -1, 0, or 0, 1, or 0, -1, depending on the direction of the mouse point. So now add, we're going to make new index. We're going to add. Basically, we're adding this either 1, 0, 0, 1 and or 0, 0.0. If it doesn't fit any of the criteria, it'll just be 0, which means new index is going to be the same as moving index. So so as long as that's not true, so if new index is not equal to our moving index, so if it has been added onto, then we want to make a new position. So we're going to need to get a position with an index, which you can see here. We kind of already have a built-in function for it. I'm just going to make it be able to get grabbed from this match-3. So public vector2 get position from point. And then we're going to do a point p, and from here we're going to do p.x, p.y. We're going to return this. So get position from point. So basically we're just kind of converting it into that anchored positions. We're converting a point in our 2D array to the position of it in its anchored position. So now that we did that, we can use that get position from point new moving index. So we're getting the position of the current piece that we're moving, its normalized or its normal position where it's gonna rest. And what we're gonna do is we're going to add point. We're going to add a new point at x, but a negative y, because how it works is since it's top left, going down is, we don't want it to go up, we want it to go down if y is greater, or the larger the y, the more down it should be. So that's why we do a -1, and we're just gonna do 16. So basically, and we want a 2 vector. So basically what we're doing is we are gonna change the position that we want the piece depending on the direction that we're gonna add to it. Sorry. And then we're going to add the position by that 16. So it's kind of offset the piece a bit if we're going to move it, so we can kind of indicate what direction we're going. And I'll show you that when we get there. And then, so if we're moving, we want to move the moving piece. So I think we only have reset position in there. So we're going to go back to node piece, and we're going to create a public void. We're going to move position 2, and we're going to take in a vector 2. And what this is going to do is we're going to move the rect transform. So the rect anchor position is going to be moving. So I'm just going to lerp it because it's easy. We're going to move the anchor position to our position here. Oh, actually, we have this name. Let's just name it move instead. So we already have position set up. And then we're going to do time delta 16. I'm doing 16 just because it's 64 by 64 is each piece. So 16 is just 4 divided by that. So it's not too fast, not too slow. And we'll also just kind of clone this, and we're going to do move position. This will basically do is we're going to add a position onto it instead of lerping it. This we might just use later on, just figure save us some time and write it now. So the move position's taking a direction and moving it in that direction. The move position 2 is taking a position and moving it to that position. So I think we're out, then we're set. And then we want to call in, we want the piece that we're moving needs to move to, because we're not adding a direction, we want a specific position, which is pause. So that's if moving is false, but moving is null. If it's not null, then we call all this, but moving is always going to be null for now. So let's see if we can add a new function. We're going to be moving a piece at this index. And what this is going to do is if our moving is null, it's not null, we're going to return. So we're not changing a piece up while we're already moving another piece. Then we're going to set moving equal to, we're going to need to get a piece, or, we can just do a piece, right? You don't need to find a point and do all that. So node piece. So if we want to move a piece and moving is not already being moved, then we're moving it, and then mouse start is going to equal our input mouse position. So we're getting the start when we move this piece. We're setting the piece to moving, and yeah. All right. And what we're gonna do is we also got to do the drop piece. So we already have the piece that we're moving. So if moving is null, it's the opposite, then we want to return, because if we can't drop nothing. And what we're going to do is this is where we're going to move, or basically flip the pieces around in the game board. Then we're gonna we're gonna reset it. Actually, let's for now, because what we're gonna do is because if our new index is equals to moving dot index. So if we're not really moving anywhere, then we just want to reset the piece. So moving dot reset position kind of thing. We actually, I don't think we can. Okay, drop piece will work on, but for now. So what we're gonna do is we're going to be flipping the pieces around in the game board, and then this is only if moving, or Sorry, I'm thinking. So if new index does not equal moving index, then we're gonna flip the pieces. Otherwise, we're going to reset the piece back to original spot. And then we're just going to set moving equal to null. Or we're gonna do that now. So for now, since we won't really know because it doesn't do anything, let's just log dropped. So we have our move piece, so let's go into the node piece here. On pointer down, we're saying we're grabbing it. What I'm gonna do, I'm just going to take them. We're gonna call move piece. So luckily, since we have that static instance, we're gonna use that, and then we're gonna call move piece, and we're gonna just say this. So we're gonna move this piece, and then on pointer up, if then we're gonna do move pieces instance. We're gonna try, or we're going to do the drop piece. All right. So now that moving pieces should be something. Let's see if I grab it. Okay, so you can see it kind of has pre-estimated guess of where we're moving, but the up and down is backwards, so I might have messed that up somewhere. So let's go back. So we're adding the new point. Maybe this should be positive. Maybe I can just do add. Multiplying add by 16 to vector. Let's see if that works. Whoa, sorry about that. Okay, so now it's working. Once we let go, it's gonna be dropped. You can see we dropped, but it's gonna just stay there because we don't have any code to reset it back to its normal position. So now that we have them moving, what we need to do is we basically need to flip the pieces and check it, and then or reset it back to its original position. That's all going to be done within the match-3 that we can see here. We're going to throw it into here. So we're going to do a public void. So if we get it wrong, we're going to just reset a piece. And we're going to need a node piece. So we're going to reset a piece to basically back at its old position and just kind of figure it out from there. We are also going, and for this, we're going to call that reset position that we have. So it grabs a new position, and then we're going to have to update its position over time, but I don't want an update function within the node piece. That's why we have this update piece kind of thing. So what I'm gonna do here is let's figure this out. So like I said, we're gonna return true if I need to keep updating. I'm gonna return false if I don't, or if I'm not. Yeah. So if to return true, our distance between the rect transform. What are you doing? Rect dot anchored position to the position that we want. Then if that is greater than 1. So if it's greater than 1 pixel away, then we want to keep lerping towards our position. So rect. So what we can actually do is let's just call move position 2 using our POS position. So our rect anchored position is going to move to this position, and we're gonna say that we are updating, so we can't grab it while we're doing this, and then we're going to return true. So yeah, we're still moving. Let us move. Return true. But if our distance is it, then we're going to just we're going to just set the anchored position directly to our position that we want, and we're going to say we are not updating anymore. Let's do some more stuff. So there you go. Now what we got to do is we got to find a way to call these, but without having an update on each piece, because that wouldn't be very helpful at all. So let's create a update function here, and what we're going to do is we're going to just kind of keep track of all the ones we should update. So let's do a list of a node piece, and we're just going to call it update. On start game, let's set that update to a new list of the node piece so it's not null. And what we're gonna do is right here, we're gonna do update. Let's add the piece, because we're gonna reset the position, which you can see here. It basically sets the position that we are gonna update back to its original location in the grid, and then we're going to move to that, because in this update function, what we're going to do is we're going to loop through all those update node pieces and basically call that update function, really, is all we're going to do. So I is less than update dot count, and then I plus plus. We got to figure out if we should update it or not. I'm just going to say updating. So if we're updating, it's going to look for that. Let's just grab this called node piece. So if our piece is updating, so we're going to call the update piece. It's going to return true if we still need to move. It's going to return false if we don't need to move. So if we do not need to move, I guess we can just throw this into one here. So if we do not need to move anymore, then what we're going to do is we're going to remove it. But we can't just remove it from update right while we're looping through it. So let's just create a new list. Let's just call it finished updating. So we're going to create a new list that basically holds all of the ones that we've finished updating. Piece. So we finished updating this piece if the update returns false. So if it's in its position, then we want to add it to our finished updating. And now what we want to do is we want to loop through finished updating, and basically grab this piece again. What this is doing is, since you stop moving, let's kind of check you out and see what needs to be done. So for now, what we're just going to do is we're just going to remove the piece from update. So once it's done updating, remove it from update, and we're good. So now that these are being called, once we reset the piece, we should be able to kind of finish off everything. Or it's going to move back to its position when we let go. So let's do that. So node piece, let's go back in. Move pieces. So let's just let's finish this. So let's do game.reset piece moving. So let's reset the moving piece, and that would be if the index update with parameter types. Do I have it? Oh, it's already in there. Get out of here. Sorry, I just had an update function already in our Match-3. There we go. So we're gonna hit play. So now when I let go, it's gonna move back to its position. Okay. That worked. So let's flip the pieces now. So you know when to check it, you move the two pieces, check it, and then if they're not, then we're gonna move them back. So we kind of need to keep track of what piece we want to flip. So let's add that into our node piece. So we're gonna hide it so we don't see it because I don't want to. And then we're gonna make a public node piece, and this is gonna be called flipped. Let's just call it flipped. For now, it's just gonna be null. So we'll set flip to null in here as well. I'm gonna do that. So flipped is null. So this is gonna hold. So if we switch two pieces, we need to keep track of where to switch back. Basically, this just kind of handles that. So let's go back to move pieces let's go here, reset piece. Let's just double down on that. If we reset the piece, we don't want it to flip at all. So let's just set that to null. All right. So what we kind of have to do is gotta figure out which pieces are going to be flipped, or basically call a function to kind of flip the pieces. So under reset piece, let's create a new function, flip pieces. And we're just going to take 2 points because we're going to need to access the node. Which, speaking of which, I should add in a function for. So node, get node at point p. So what this is gonna do, basically return board at px py. Flip pieces. We're gonna need the first node, so I'm just gonna say node 1. Let's get node at point 1. We want that node piece that's connected to it, so I'm gonna call it piece 1 is node 1's piece. Oh wait, do we not keep track of? I don't think we keep track of that. All right, hold on. Let's go into node. Let's add a public node piece. So we need to kind of keep track of all that. So let's do a public void set piece with a node piece p. Let's see, set piece equals to p. We gotta set our value when we do this because we want it to be the same value as the piece that we have. But if the piece is null, let's just set it to a whole. If the piece is not null, let's do piece value. If piece is null again, or we just want to return, otherwise we will just set our index to this index kind of thing. And then we want to get function. So let's do node piece, get piece, and we're just gonna return piece. Pretty simple. Now we're gonna set the pieces for each node when we create them. So let's go back to instantiate. Let's do get node at point. Yeah, let's just go node equals get node at point, new point xy, and then here we can just do node value, and then down here let's set this to piece, node dot set piece to piece. There. That's better. Alrighty. So now we keep track of all those pieces. Let's flip these pieces. So let's get node 1 get piece. And if I set that to public, let's just get rid of it because I don't need it. Public. There it is. Okay. So we're getting the piece, but we don't want to flip pieces with holes. So let's do that. Like, just trying to think of how. Let's see here. Okay, so let's get the value. It's the easiest thing at 1. So if there's a hole, or let's just do nothing. If it's not a hole, then let's get all that stuff. Now let's get the value at the point of 2. So if the one we want to flip with is greater than 0, then we're good. Let's flip them. Otherwise, let's just reset the piece that let's just reset the first piece. So in here, what we gotta do is we gotta grab the second piece and then basically switch the pieces and set flipped, and then add them both to update. So let's start with that. Node 2 equals get node at point 2. Node piece equals piece 2 is equal to node 2 dot get piece, and then node 1 dot, we're gonna set the piece to piece 2, and then node 2 is going to set the piece to piece 1. So we're flipping the pieces. And since we are flipping the pieces, let's set the flipped to the opposites. And then let's add them to update both pieces. Okay. But if they're both set when we okay. So let's try. Okay. Let's see what happens now. So we should probably call it. That might help. So here we got the else. So if new index does not equal our moving index, let's call game.flip pieces using moving index and new index. So flip the pieces if new index does not equal moving index, kind of thing. Let's see what happens now. So let's flip these. Okay, so side to side works, but that's backwards. Okay. Interesting. Very interesting. So maybe that was important. Go back to add x and then negative add y. But, oops, sorry. I'm trying to think here. Oh, that was backwards too, wasn't it? See, now it's backwards. But at least that works. Maybe, you know what? I think it's this. So in here, yeah, because, okay. So yeah, I got confused. So it starts at 0 at the top and it increases in y at the bottom. So if y is greater than 1, we actually want to subtract 1. And then, because if we move down, we want to increase 1 spot. If we want to move up, we're actually minusing 1 spot. So here, it's right here. So if the dir magnitude is greater, so if we're moving it, and if y is greater than x in the absolute value, then what we want to do is basically what it was is there's a 1 here and then a -1 here, but that's not the case because it starts at 0 at the top and increases in value at the bottom. So if we want to, if our direction of the mouse is going down, what we actually want is to go up. So this one is checking if the direction of the y is going up. What we actually do is we want to go down. So make sure it's new point 0 ender, and then do ender dot y greater than 0, check, and then for the first value it's -1 and then 1. Okay, now that we got that, now it should be correct. Hey, there it is. So now we can move the pieces and they flip and it looks pretty. There it is. Yeah, okay. So moving works. But in these games, we only want to keep them flipped if there is a match. So what we're going to do is up here, since we're finished updating, what we're going to do is actually, let's see something. Let's actually get rid of this flipped. What we're going to do is we're going to kind of keep track of the flipped within the game and not all these pieces. So let's get rid of flipped and let's just comment this out so I know exactly where to put it. Now what we're going to do is we're going to come down here and we're going to just create a new class. And where this is going to be a public class flipped pieces. And here it's just going to hold a public node piece first, or 1, and then public node piece 2. And we're going to create a default constructor to just kind of fill these pieces. 0 node piece t. So 1 equals O, and then 2 equals t. Here with the flipped pieces, what we want to do is we want to create a new list of these flipped pieces, call it flipped. So, and then we're going to come down here where we start the game. Sorry, I was trying to find this. And we're going to create a new list. And then when we flip them, what we want to do is we want to add a new flipped pieces using piece 1 and piece 2. All right, I think that will work a lot better than holding in a value at each piece. So now we have our flipped. What we're gonna do is now we kind of have to figure out when to check them. And luckily we kind of already have a perfect spot for it. So in our update function, you can see here we remove the update piece when it stops moving. This is also the perfect time to check whether or not we should actually flip it back or not. So here, what we can do is, what we need to do is create a new list of our point. Because remember, the isConnected returns a point list of all the values that are connected to it. So that's what we're going to do. We're going to call it connected, and we're going to get it from isConnected. The p value is piece.index. And it is the main, it's the first time we're calling it, so let's put that as true. So now what we got to do is we got to figure out whether or not we flipped or not. Because if we flipped, what we actually want to do is we also want to add the points of the one that we flipped. So what we're going to do is we're going to come down to the flip pieces class. We're gonna just take public. We're gonna be return a node piece, and then what we want to do is we want to kind of get the other piece, kind of. So if, and then check if p. So if p is equal to 0, or sorry, 1, then we want to return 2. Else, if p is equal to 2, we want to return 1. Otherwise, it's none of them, and we return null. Right here. And then what we want to come up here, and we want to add, so we want to, we got to check that whole list though. So we're going to do a node piece. Get flipped, and we're just going to check basically the piece, kind of like we did before, but what we're gonna do now is we're going to loop through return through our flipped pieces. So I is less than flipped count, and then I plus plus, flipped at I dot get other piece p. And then what we're gonna do is if piece does not equal null, let's just break it so we know that it's fixed, kind of. So we're gonna flip, it returns null if this piece is not in the flipped, and it might not be, so it'll return null, and then basically we can return the piece that it needs. So let's do node piece. Let's just go up here next to this other node piece. Let's do node piece flipped piece, and let's do get flipped using piece. So this is going to call it, this is going to be null if we didn't flip it. So like if it dropped, basically, because when pieces drop, they're also going to be in the update. They're also going to finish updating. But if we did flip it, so if flipped piece does not equal null, that's not how you spell null. So if we did flip it and it found a piece that it was flipped with, then what we're going to do is we're going to add the points using this connected list. What we're going to do is we're also going to add the points that are connected to this flipped piece, and we're also going to say this is a main call. So we're going to basically add in all of the extra pieces from the flipped one as well. So if we, let's say we have, so let's say we have these 3 pieces, but this is a O here, this is an X, and this is OO. So when we flip these 2 pieces right here, let's move it in. So when we flip these 2 pieces here, what it's going to do is it's going to make an X, and it's going to make an X going down and an O going aside. But so when we get this first, right here, once we get this first connected, it's only checking the first piece we moved. So that would be this X if we grabbed it. And so it's only going to get these 3 X's. We also want to grab these 3 O's as well. So that's why if we did flip it, then we want to add the points of the connected flipped piece as well. So we'd get these 3 O's. And so now if our connected is not 0, or if it is 0, actually let's just reset it if it's 0. So if it's 0, which means we made a move that didn't account for anything. So what we want to do is we basically want to move that piece back if it was flipped. So we have to check if the flipped piece is not null again. So what we can actually do is we can just kind of create a bool of was flipped. And so if it was flipped, then we want to add the points. And if it was flipped, let's flip it back. Flip pieces. Let's flip those pieces back. So piece index, flipped piece index. But what this is going to do is when we flip them, it's just going to add it back into the flipped pieces. So let's make sure that we can, let's just say main again. So if main, then we can flip them. We can add the flip. But if it's not the main, let's not flip them back. So you see here it was flipped and we just want to flip them back. So this would not be a main. And then we're going to have an error somewhere. It's in move pieces, right? Yeah. And this is a main because we would want to flip them back if we want to add it to that list. Okay, but if we do have some connected pieces, that means we did a good move. So what we want to do is we want to kind of loop through all the points in the connected list. And here we want to grab all the nodes that we get node at point and all their pieces. I guess I can't call it piece, huh? I'll just call it node piece. Yeah, that works. And then we're just gonna call it node get piece. And if our piece does not equal null, actually, if it was flipped, we should probably thinking how we should do this, because we need to remove it. We need to remove the flipped when we flip it back. We should actually just remove the piece or the flip anyway, even if it's like, as long as it was flipped. So we need to do, let's see here, get flipped. Let's just remove flipped from a piece. Let's try this. It's just a void. Alright. So we're using a P here. And then, so trying to think here. Let's just call it the flipped piece. And then if we're not returning null, let's set piece, or let's do flip. So we're removing it, so we want to grab the flip using a piece. So if the flip, you get another piece. So if we're finding a flip with this piece in it, then we want flip to be set to this flipped. And we want to remove it. So what we can actually just do is we can just, let's just I'm just trying to think of the best way to do this. So let's just get the flipped kind of like this instead and return the flipped pieces. And not just the piece itself. And so let's return flip Seems right. So now when we get up here, when we get the flipped, it's not gonna be a node piece. It's going to be a flipped pieces. We're just gonna call it flipped. So flipped get another piece with piece. So we're still getting flipped piece from this flipped pieces kind of thing. There. Okay. Because we know it's getting the flipped with that, so we can do that. And then what we can do is come down here when we do the flipped, we can just remove. Oh, because we named it flip. Just call it flip, please. Flipped, remove, flip. So we're removing that flip that we did, no matter what, really. Okay. I guess what we can do is we can get rid of the piece. So let's just for now, let's just set the piece or the node piece or node piece. I get confused. So if node piece does not equal null, let's set it to false, and then node, let's set this piece to null. So basically what we're doing is remove the node pieces at this when connected, and yeah, that's basically it. Remove the node pieces connected. Else, let's just make some comments. So this else is being called if we made a match, if we didn't make a match. Maybe we can just do flip as null, right? We set flip to null. So if we flip, then we want to flip back. If we made a match, let's remove the nodes connected. And then remove the flip. Okay. That should work. We will see, I guess. So when we make a connection, they should go away. Probably gonna get some errors. If we don't make a connection, it should go back. So let's not make a connection. Oh, we made a connection. Oh, but we got an error, but that's okay. Oh, it's not okay. What's on? Flip pieces, get other piece from piece. It's gonna give us, it's giving us null. Why did I open that up? Okay. No, why did I open that up? Let's see here. Okay, so we're not checking if it's flipped. Okay, hold on. But we do get a null, right? But we let me just set that back to flip piece. Because we don't want, hold on, let me think this through. Okay, so it's giving us this flip is null, which would make sense because if we are getting a null, then we cannot grab this piece. So let's just flip this back. Okay. All right, let's add this into here. So if we did flip it, then we want node piece in here. Then let's just do it. As null, let's just call it. Okay. I mean, technically, we don't need that. So let's see how this works now. So what was going on is I was setting it even though I wasn't checking it before, so when flipped would return null, it would still try to grab try to grab that other piece, but we can't do that if there's nothing there. So we checked it, boom, it's gone. Let's make a bad move, flips back, bad move, flip back, bad move, flip back. Okay, so you got me, made a nice little L there. Boom, they go away, they go away, go away. See, we can't do a 0 there. I might change that. Flip, flip. See, the 2x2s work as well. 2x2s count. Get rid of that. Okay. So now what we need to do is we basically need to apply gravity and kind of fill in these spaces. But that will be for the next episode. So thank you all for watching. I hope you are enjoying following along. We're getting there. I think only a couple more episodes maybe, unless I want to keep doing more with it. So next episode, what we'll do is we'll be able to apply the basically gravity to all these pieces and kind of refill the pieces that we get rid of. All right. Thank you.